Question number 2 says, what can be deduced from the ratio test about the following series? So we're taking a look at 2a, n squared over n cubed plus 1, and the sum of that series. So we're going to apply the ratio test. So I've written the ratio test here. We have the an plus 1 term compared to the an term, and we're seeing if that limit is less than 1. So writing out the an plus 1 term for a, we get n plus 1 squared over n plus 1 cubed plus 1, and that's going to be over the original n squared over n cubed plus 1. So I'm going to rearrange this. So we're going to end up with the limit as n approaches infinity. So the numerator terms are going to be n plus 1 squared. It's going to be n cubed plus 1. And in the denominator, we're going to have n plus 1 cubed plus 1. That's all one factor. And then n squared is the other factor. Okay, now looking at this, this is really just a polynomial expression in the numerator, a polynomial expression in the denominator. So we can basically see that, compare the degree of the numerator and denominator. So we have an n plus 1 squared, well that's a degree 2, times a degree 3, so we have a degree 5 in the numerator. We have a degree 3 in the denominator with the n plus 1 cubed, and then we're going to multiply that with a degree 2 n squared, so we're going to have equivalent degree numerator and denominator. So we could all expand this all out and do kind of a formal cancellation of this, but really the reality is it's a degree 5 over degree 5, so we just need to compare the coefficients on the degree 5 term. So we're going to end up with a coefficient of 1 in the numerator, a coefficient of 1 in the denominator. So the limit really is just going to be equal to 1. Well, our ratio test requires that we find that the limit is going to be less than 1. Not equal to 1, but less than 1. So in this case here, this is inconclusive. Okay, so I'm just going to write that out. So my limit equaling 1, this means that this is an inconclusive test.